Hi everyone. So welcome to supplementary video 13. So this video is actually just sort of demonstration of some one of the results that I gave in the class today in lecture 17. So in lecture 17 we were discussing flow past a sphere, and we said E4 of psi is equal to 0, where E square is uh, del by del r square, del square by del r square plus sine theta by r square by del theta of 1 by sine theta del by del theta. Okay, so this is what was given to us, and we said based on the boundary condition, what you want to do is you want to substitute psi as f of r sine square theta. Okay, and then that will give us a new condition, new equation in f of r. So what I want to do is I want to derive that condition of f of r, which I kind of gave it to you, and we had to almost accept it. So let's try to do that together. So first let's try to do that. E square of psi becomes E square of f of r sine square theta. Okay, or this becomes I should clarify that E4 of psi is E square of E square of psi. Okay, so first you want to do first, we'll do the first operation right now. So this is becomes del square by del r square plus sine theta by r square del by del theta of 1 by sine theta del by del theta of fr sine square theta. Okay, this is what you want to do. But first thing you can see is, because the first derivative is pretty simple, this term on this operator is very simple, because the only function of r is f. So sine square theta will simply come out. So this will become sine square theta of del square f by del r square. Okay, right? The second term, f of r will come out. F of r is not a function of theta. So I can write this as sine theta by r square f of r del by del theta of 1 by sine theta and del sine square theta by del theta. Okay? So this is my description. So what I've done is, you can see that here I've only taken the sine square theta term, and here basically I've only taken the f term, and that's because the first operator is only a function of r, and the second operator is only a function of theta. So that's how I have done this, and they simply become multiplication factors, the remaining terms. Okay, so hopefully this is clear. So let's do this again. So now we have sine square theta del square f, rather you should write d square f, because f is only a function of r, d square f by dr square plus sine theta into f of r by r square, and del by del theta of 1 by sine theta. Now let's the derivative of sine theta with theta. So sine square theta derivative is 2 sine theta, and derivative of 2 sine theta is cos theta. So this will become 2 sine theta cos theta. This gets cancelled, or we get sine square theta d square f by dr square plus sine theta f of r by r square, and the derivative of cos theta is minus sine theta, so this becomes minus 2 minus 2 sine theta. Sorry, derivative of cos theta is minus sine theta, this becomes minus 2 sine theta, or finally we get this sine square theta to d square f by dr square is minus 2f by r square. Okay, so this is e square of psi, or rather this is what we get, or e square of f sine square theta. Okay, now so one approach is that we basically do the same thing again like I did just now, and try to get the result. The other thing is, we can see a pattern emerging, is that the sine square theta has come out, the sine square theta had gone in my input. So other way I can say is to calculate E4 of psi, right? So this is what I want to do, basically calculate, right? Or I can say that, let's just say that this is something of from E square G of sine square theta, right? Where G is 2 square F by dr square minus 2F by r square, right? That's what I want to do essentially. I want to operate the E square operator on G sine square theta, where G is this function. But because you can see that we have already calculated what happens when we do on f of r sine square theta, this essentially means that I will at the end get d square by d square G by dr square minus 2G by r square sine square theta, or the way it was given, or you can think of it like this: d by d square minus 2 by r square of G sine square theta. And now G itself is this function which is given here. So this becomes d square by dr square minus 2 by r square is d square F by dr square minus 2 by r square sine square theta. And finally, this becomes d square by dr square minus 2 by r square whole square of F. And there is a sine square theta there. And this is the value of E4 of psi. And this is equal to 0. We can, of course, say that sine square theta will not be always 0. Or finally, we get d square by dr square minus 2 by r square whole square of F is equal to 0. Okay. So I hope this sort of helps. You can see how we came from the equation of E4 psi and substituted FR sine square theta. And then once you do that, you take the derivatives. You can see the first derivative is only with respect to R. So you only take the derivative with respect to F, and just sine square theta becomes a multiplying factor. Then you only take the derivative with respect to theta of sine square theta. F becomes the multiplying factor. You simplify, you get something, a factor, now d square F by dr square minus 2 by r square, which is this term, multiplied by sine square theta. And now we want to take another operator, which is the same operator again. But we say, well, why do all the hard work when we can just simply say this is a function of r, like g of r, and we can just simply use the result we derived earlier to write it as d square G by dr square minus 2G by r square, where G is that function which was calculated in the first step. And essentially, we get the square operator equal to 0. So I hope this was helpful. We couldn't do this in class due to lack of time. If you have any questions, feel free to let me know. Otherwise, I'll see you in the next video.